Creating high-quality computer graphics isn't easy. It involves dealing with huge amounts of complex 3D data, coordinating with different artists working together, often collaborating with other teams around the world. All this while translating between different file formats. Now, what if it could all be easier, faster, more efficient even? That's where USD comes in. Universal Scene Description, or USD for short, isn't just a new file format. It's a common, universally understood language in the 3D world that is revolutionizing digital content creation. It's changing how we create visual effects and animation. We have all had to grapple with an alphabet soup of file formats, like ABC or OBJ or FBX, or any of the proprietary formats. Each one capturing only a fraction of the 3D scene, and piecing it all together isn't the easiest of tasks. Moving this data between departments or different softwares has also been a difficult feat. The team at Pixar saw this problem and came up with an elegant solution in the form of USD, a universal way to describe all of your complex scene data. Just like how HTML provides the structure for your web pages and tells your browser how to display them, USD lays out the framework for 3D content creation, providing a universally understood structure and language. It's fast becoming universally understood amongst DCCs. Let's break down the key elements of USD. Imagine a theater. The USD stage is like a theater stage. It's where all the elements come together to form a composition. Now, any single thing that contributes to this composition is called a prim, or primitive in the USD world. They are the basic objects in USD, such as lights, geos, cameras, etc. Continuing with the theater analogy, consider each department that contributes to the final stage production. The set designer, the lighting technician, the costume team, and so on. In USD, each contributor makes their changes to a specific layer, modifying our scene without permanently changing the underlying base. Layers are the contribution of each department or artist into the final composition on stage. Now, just how you might have different costumes for the same character or variations of the same set, variants in USD work similarly. There are multiple options stored within a single object or prim, like a cup of coffee that can be switched between being an espresso, a cappuccino, or a latte. Additionally, USD comes packed with some standout features like the composition engine, which lets you combine data from multiple layers or sources, similar to how Photoshop composes 2D layers. Schemas, another key element of USD, are like blueprints for your prims. They allow USD to comprehend the function of a prim or its attributes. You can even create custom schemas to define your own specific set of properties or create entirely new prim types. USD is completely file system agnostic. It doesn't need to know where an asset is physically stored. Anytime USD needs to access an asset, it calls upon the asset resolver. Think of it as a little black box that takes an asset identifier string as input and spits out a loadable file path. Hydra essentially acts as a middleman between USD and your renderer. It does that by transporting live scene graph data to your render engine. Let's dig a little deeper into prims and look at some of the vocabulary around it. Starting with leaf, which describes the position of a prim in the scene graph. A leaf is at the end of a scene graph tree hierarchy. Then there are the prim types, which define what the prim actually is. Is it a mesh? Is it a light? Or anything else? Lastly, we have kind, which allows you to define where your prims go in the scene hierarchy, whether it's a group, an assembly, a component of it, or a subcomponent. We've broken down the jargon and largely decoded the mechanics of USD. Now, let's take a look at what working in USD might actually look like for you. Picture this. You're working with a friend on a live document on the cloud, say Google Docs. You both are editing in real time, making changes and updating information. Now, translate that fluid, collaborative experience to 3D content creation, where instead of editing text, you're manipulating 3D data. Using USD, you can manipulate lights in Katana while your friend adjusts the geo in Maya. Even though you're using different digital content creation tools, you both are working in real time on the same USD stage. USD opens the door for parallel pipelines with multiple departments. Artists can collaboratively work and contribute to the same parent-level USD file, building complex asset structures along the way. All this while controlling this enormous amount of data with what USD calls opinions. The contribution of each artist or department, any modification they do on the USD file is regarded as an opinion in USD. These opinions are stackable and are prioritized based on their strength, with stronger opinions overriding weaker ones. The stronger an opinion, the higher its impact on the final composed result. And this is how multiple departments can work in parallel, editing and updating the 3D world in real time. This is what makes USD the game changer in the VFX and animation industry. So by now, I hope you can see what makes USD an extraordinary tool. It provides a standardized language, allowing complex data structures to be shared amongst different DCCs. This allows you to use the best tool for the task, from start to finish. And the best part? It's open source.